Alright, we're going to factor here by grouping. I use the grouping method whenever I have 4 terms. If you look in these problems, they're all going to have 4 terms. Alright, the first step that I always use when I'm factoring, it doesn't matter how many terms there are. I look for a greatest common factor at GCF. So I look at each term and I decide what I can divide them all by. And I see that I can divide by a 3. Not all 4 terms have an x, so I leave the x out of this, and only 3 is the greatest common factor. So what I'm going to do from here is I'm going to start with a bracket. A bracket's the same thing as a parenthesis, and I'm going to write what I have left. So 3 times 9, or 3 times what gives me 9, and that's 3. And then I need an x cubed here. 3 times what gives me negative 12, well, that's negative 4. And I need an x squared. 3 times what gives me 9x? It's going to be 3x. And 3 times what gives me negative 12? That's negative 4. And then I'm going to end my brackets. I could always, if I wanted to, check to make sure that I did this correctly by doing 2 things. One, I could distribute the 3 back into the problem like this with all these arrows and see if I ended up with my original problem, my original expression. I would in this case. And I also look inside the brackets and make sure that I can't divide by a number bigger than 3 or another number. That would tell me if I could divide by something else that I didn't originally take out the greatest common factor. So let's see here. Let's go back to, there we go. Let's get rid of that stuff because we don't need it. The next step is to keep the 3 out here, and since there are 4 terms inside the brackets, we want to make 2 groups. So I'm going to take the first 2 terms and put them in a group, and there's always a plus right in this part in between the 2 groups. And the second 2 terms, and I'm going to make another group. Okay, and that's why it's called the grouping method. Alright, the 3 stays out there. The first group, I pull out a GCF. X squared, since both terms have an x, I pull out an x and I pull out the smallest exponent, and what's left is a 3 and an x, 3x, and minus 4. From my other group, the only thing I factor out is a 1. I'm going to do that though, and that leaves me with 3x minus 4 because I factored out only a 1, so that doesn't change anything. Alright, again, you could distribute the x squared into the first group and you would end up with the first set of parentheses here, and you can distribute the 1 and you're going to get 3x minus 4. Let's see, we'll go back to a different pen here. For the final answer, we're going to keep the 3 that was all along outside, and we're going to look at the 2 pieces that we have on the inside separated by the plus sign. Those 2 pieces have 3x minus 4, that quantity in common, so I'm going to factor that out. They both have that. I can divide it out of both pieces, so I'm taking it out. What's left? Well, if I factor out that 3x minus 4, there's an x squared left right there. And if I factor out that 3x minus 4, there's a 1 left, or a plus 1. So that's my answer. I'd say 3 times the quantity, whoops, 3x minus 4 times the quantity x squared plus 1. Alright, let's look at another problem here. Let's see. Okay, first thing, GCF. GCF is 6. I'm going to figure out what's left. Well, that's a cubed plus 6 times 8 is 48, and there's an a squared left, minus 1a, so yeah, minus 8. Okay, I have 4 terms inside the brackets, so that tells me that I'm going to try grouping. So I make 2 groups. Even though this is a minus a right here, I'm going to put a plus. It's always a plus. I put my minus a right there. Alright. Once I have my groups, I pull out a common factor if there is one from the groups. That was the reason behind making the groups. A squared is my first common factor, so I'm left with a plus 8. And if I look, I'm going to circle this piece right here. If I look right there, I see that I have a negative a minus 8, and I want it to be a positive a and a positive 8 because that's what I have in this set of parentheses. So at this point, this is where you have to think a little bit. I'm going to factor out a negative 1 from that set of parentheses, from that second group. And when I factor out a negative, that changes both signs. So this negative a becomes a positive a, and the 8 becomes a positive 8. If you don't believe me, distribute the negative 1 back into the parentheses, and you'll see that it's negative a minus 8. And what that allows me to do is to write my final answer, which I keep the 6. I look at what this piece and this piece have in common, and they have that a plus 8, so I can factor that out. And I can look at what's left. From here, I have a squared left after I factor out that a plus 8, and I have a negative 1 left from this piece right here. Okay. If anybody was watching this that knew a little bit more about factoring, you would know that this isn't actually the final answer. This last factor right here in the quantity a squared minus 1 is called a difference of squares, and it could be factored further. But we haven't gotten that far yet, so we're going to leave this as our answer for right now. Alright, let's see here. We'll do one more problem maybe. Let's look at... There's the oven. Alright, let's look at number 3. So if I look at all 4 of these terms here, I'm limited when I'm finding the GCF by this last term, this 12. And it's not always the last term, but it's the smallest coefficient, that I'm limited by, because the biggest number I can divide all 4 of these by would be 12. I can't go higher than 12 because I can't divide 12 by 12. So I can't divide all 3 of these terms by 12. 21 isn't divisible by 12, and neither is 63. So what else can I divide 12 by? Well, I can divide it by 6. Can't divide 21 by 6. I can divide it by 4. Can't divide 21 by 4. So 3 is going to be the largest common factor that I can divide by. So I start brackets, and I'm left with 21m cubed minus 12m squared minus 7m and plus 4. Alright, look, 21, 12, 7, and 4. I can't divide anything else out of there or factor anything else out, so that was the right number, this 3. Okay, I keep 3 and I make groups. And I'm making groups because there are 4 terms on the inside of my brackets. See that minus there? I don't care, I put a plus. The minus goes right here. Okay, that just saves a lot of headaches if you make that a plus, because then you don't have to change the sign on the 4. Okay, let's look in our groups and try to find a GCF. Well, I see that we have a 3 that I can still factor out and an m squared from this first group, and that leaves me with 7 because 3 times 7 is 21, and I need an m because m squared times m gives me the m cubed that I originally had, and then minus 4 will be left. Now look up here, I have a negative 7 and a positive 4, and down in this set of parentheses I have a positive 7 and a negative 4. That tells me that I have to factor out a negative 1. So I'm going to put a negative 1 right here. I'm doing it in red to highlight it. That changes my sign to a positive 7 and a negative 4, which is what I wanted. And so my final answer is going to be 3 times the quantity 7m minus 4, because that's what each piece has in common right here. Okay, and then what's left from each piece? Well, there's a 3m squared left, and there's a minus 1 left, so that goes in my last quantity there as my final answer. Alright, so anytime you're factoring, and even with grouping, you look for a GCF. If you don't have one, you can still group. For instance, if let's say there is a GCF here, but let's say there wasn't, I could always take these 4 terms and make 2 groups right from the very beginning. I don't want to do that since there is a GCF, but if there wasn't a GCF, we're pretending, we'd make 2 groups just like that. and go from there. Okay. So you're always looking for a GCF. After you look for a GCF, if there are 4 terms, you try to group. Is it always going to work to group? It isn't. But if it does, if you end up like we did in number 3 with 2 sets of parentheses that are the same, you can factor that out. That's going to be the second factor. And then the last factor is going to be what was left. In our case, in number 3 was 3m squared and the minus 1. That's how you get the job done. If you are still confused, you can always play the video back, watch it a few times. It doesn't hurt to practice and reread and rewatch. I don't even know if rewatch is a word, but the video more than once. There are plenty of places online that you can go to find information about this. There's a website called Purple Math that there's a link to on my website, or you can just type in Purple Math. It's pretty good. You can go on YouTube. I'm sure there's people that are a lot smarter than me on there that are making videos that might be able to explain it a little bit differently. But use your resources. You can watch it while you're looking at your phone or whatever, text messaging somebody. So there's really no excuse to not know how to do this stuff. Alright, that's it.